Hello everyone and welcome to the Top Hat Learning Lab. Today we'll be solving candy distribution problems. So what are candy distribution problems? Well, these problems deal with the distribution of objects such as candy to different recipients such as people. Different distributions may result in leftover candy or you not having enough candy to finish this distribution. If you don't get what I'm talking about, here's an example. On our top left-hand corner, we have our first problem. You have a pile of candies and a number of friends. If you give everyone 2 candies, there are 12 left. If you give everyone 3 candies, you'll need 2 more. How many friends and candies do you have? What this problem is basically saying is that you have this pile of candy, and if you distribute 2 to everyone meaning the number of friends you have, then there will be 12 unused candies. If you distribute the same pile of candies to everyone, but everyone gets 3, there might be 2 people who only get 2 pieces of candy each, or you might have 1 person who only has 1. In other words, you won't have enough to finish this distribution. So I actually have a formula that you can use to solve these types of problems, and I'll write it out here for you. So we have the leftover candies from situation 1 plus the amount that is missing, which is from situation number 2. We can divide this amount with the difference in distribution, and that will give us the number of recipients. In this case, it will be the number of friends, which I'll represent with an F. Now, what is the difference in distribution? Well, this just means that however many you're distributing in situation number 2 or 1, you want to find the difference between these distributions. So all we have to do now is to plug in numbers. So there are 12 left in situation 1, so we put 12 here, and we add 2, which is how many we need, or how many are missing in situation number 2. And we divide by 3 minus 2, which is the difference in distribution. 3 minus 2. And that will give us the number of friends. As you can see, it will be 14 divided by 1, which gives us 14 friends. We also need to find the number of candies that you actually have. This part, we just need to plug in 14 friends for everyone, because 14 friends is everyone in this case. So, since everyone gets 2 candies in situation 1, we can multiply that with the 14 friends, and we add the 12 leftover candies, and this will give us 40 candies. If you wish to use situation number 2, it would be the same result, but you would do 3 times 14 minus the 2 that you are missing, and that would give you the same result, 40. Now, where does this formula actually come from? So, this formula actually you can get by using algebra to solve the previous question or other questions of this sort. There are actually different variations of the candy distribution problem. As you can see here, this formula deals with double leftovers, and this one deals with double missing candies. For example, in the previous example that we did, if you gave everyone 2 candies, there are 12 left. But let's say if you give everyone 3 candies, there are 4 left. In this case, you'd have to use formula number 2, because there are 2 leftovers. So I'm going to use algebra to solve the previous example. So we're going to have x equal the number of friends. So since the number of friends and the pile of candies are both constant, we can write an equation. So this is the number of candies in situation 1. So this is situation 1. And this one is the number of candies in situation number 2. So now we're going to use x and write two algebraic expressions. 2x plus 12 is equal to 3x minus 2. This one represents the number of candies in situation 1, and this one in situation number 2. We can then simplify this by grouping like terms. We're going to subtract 2x, and we're going to add 2 to both sides. And this is going to give us a result very similar to our formula. Now we can cancel and regroup. And as you can see here, we have our leftovers plus missing, and that is equal to the difference in distribution. If we rewrite this a bit, this is what you'll get. Number of recipients, difference in distribution, and leftovers plus the missing amount of candies. If you want to try it for these two formulas, you'll find that it works as well. But we're going to move on to our next example. So on our top left-hand corner, we have our next problem. At Top Hat Private School, there are a number of classrooms and a certain number of students who enroll. If each classroom holds 8 students, then there will be 24 students with no room. If each classroom holds 9 students, then there will be 4 students with no room. How many students enrolled? So in this case, we have our 2 leftovers. So we're going to have to use formula number 2. So we have our difference in leftovers, which I'm going to represent with DL. And we're going to divide the difference in distribution again, and that will give us the number of classrooms. Now the number of classrooms is our number of recipients, because the classrooms are receiving the number of students in this case. And we're going to write and plug in our numbers. So this will give us 20 classrooms. Now we can't stop here because the question is asking for the number of students. So like before, we're going to plug in 20 classrooms into our situation. So since each classroom holds 8 students, in the first situation, we're going to do 8 times 20 plus the 24 leftover students, and that will give us 184 students. If we use situation number 2, it would give us the same result. You do 9 times 20 plus 4, and that also gives us 184. This is also a way of checking if your answer is correct. So now we move on to our last problem. And this one's a bit different from the rest. A frog plans to jump out of a well in a number of days. If the frog jumps 3 meters each day, he'll be out 2 days later than his plan. If he jumps 5 meters each day, he'll be out of the well 2 days earlier. How deep is the well? Well, in this case, we need to figure out what's our candy and what's our recipient. So the candy is meters, and the recipient is the number of days. So if we write it like this, because there's later and earlier, we know that we'll be using formula number 1 again. So leftovers plus missing divided by distribution difference, and that gives us the number of days. So the leftovers and the missing both represent the meters. So we can't put 2 days plus 2 days. We're going to have to convert the days into meters. I'm going to draw a bit of a diagram to help you visualize this. Let's say this is the planned amount of time. And in situation 1, he's late by 2 days. So how many meters can he jump in this amount of time? Same goes for situation number 2. How many meters can he jump in this amount of time? Now, since he's late by 2 days and he jumps 3 meters each day in situation number 1, he'll be jumping 3 times 2 meters in situation 1. And here he'll be jumping 5 times 2 meters in situation number 2, because he jumps 5 meters every day. So we'll have 3 times 2 for the leftovers, because this is what's left. And we'll have 5 times 2 for the missing, because this is what he's missing in terms of meters, because he's earlier. And we divide this by the distribution difference, which is 5 minus 3. And that gives us the number of days. Again, we'll simplify, and this gives us 16 divided by 2, which gives us number of days. And we'll have 8 days. So he planned to jump out of the well in 8 days. Now, how deep is this well? We can substitute 8 days for his plan. So since he's out 2 days later than his plan in situation 1, we'll have 8 plus 2. And since he jumps 3 meters each day, we'll multiply this by 3. And this will give us 30 meters. So the well is 30 meters deep. If you were to use situation number 2, it would be 8 subtract 2, because he was earlier, and you multiply this by 5, and it would also give you 30 meters. So that's all we have for today's video. I hope you enjoyed it, and I hope you got something out of it. And thank you all for watching. Please don't forget to subscribe, like, and comment. Hope you all have a wonderful weekend.